And this has been going since 2015. This strange dimming that happens with the star that was first noticed by the planet hunters, I believe, citizen science project looking at Kepler light curves. And this star inexplicably drops by as much as 22% in brightness. And there's no clear reason why. And there's also no infrared. So with dust, you would expect, or at least close dust, you would expect some kind of infrared signature emanating from it because of thermodynamics. Well, we didn't see that. And all we see is this dimming, and that led to many hypotheses regarding stuff like interstellar medium dust and maybe something intrinsic with the star itself, but nothing has held up. So you wrote a paper regarding periodicity, and that this star, whatever's in orbit of this star, may have a period. Could you lay that out for us?
Yeah, sure. First of all, to your earlier point around when this was first noticed, 2015, I think just for clarity's sake, the strangeness with this star really dates back well beyond that. Through later analysis of photographic plates from a variety of observatories, there has been notice of some actual dips in photographic plates dating back as far as 1935, and also some secular dimming, so some just slow general fading of the star itself since 1880. So what happened is the Kepler Space Telescope, which was observing this patch of sky starting in 2009, was detecting these strange dips for a period of years, about four years, in fact. And the dips were so strange that the AI used to flag dips just threw out the data. It just decided this is just too wacky. We're not going to pay attention to this. We're going to ignore it and just dump it. So no one actually knew this star was weird until planet hunters came along under Tabby Boyagi and decided one of their projects was to go back and look at thrown out Kepler data and see if they see anything legitimate in the data that was thrown out. And this star was certainly one that raised a lot of eyebrows. It looked real. They went back to look if there was something systematic with the data, some artifact, for example, worked with some engineers at NASA, and all indications pointed that this was real, that these were truly dips falling at the star, as you say, north of 20% in short-term dips. And that just was shocking to begin with, because main sequence stars that are of the maturity and age that this star is, shouldn't be dipping like that. You might see that with a very old star or a young star or some other kinds of large or small stars, but not this one. This one, you don't ever see that happen in the age it is. So it just was really shocking, just that data alone, let alone all the other facts that were about to play out after more analysis was done with this star. So I wrote a paper because in 2017, actually starting in 2016, Tabby began a project to start to observe the star from the ground. Now, Kepler, for those that don't know, that space telescope has died eventually shortly after the last observations of this patch of sky, 2013. So we didn't have that anymore to use. And so ground-based telescopes was really the only alternative. And one of the networks used was LCO, which comprises of a number of different observatories in different time zones to try to get as much continuity with its observations as possible. And in 2017, the very first dip was observed from the ground. It was in May, and then subsequently another dip occurred in June, and then another one in July, and then another one in August. What my paper did was I noticed that these dips that were happening and being observed from the ground lined up with a number of dips that occurred and was captured by the Kepler Space Telescope. So I lined those up, saw that potentially these dips all aligned. Just try to simplify this. I just counted the number of days between when Kepler was running and caught those dips, and when we were catching them in 2017, and it came out to about 1,574 days. There's a lot more facts go along with that, but that at the highest level, John, that's essentially what the paper really produced. Now there's some consequences to that, and I think you just pointed some of those out. So if there is a periodicity, then that means that there's something in orbit. This is not interstellar media. This is not intrinsic variability. So the star itself is not sick. It's not an extrinsic variability. So there's not a nearby star interfering with the light. It's not a black hole, for example, somehow between Earth and the stellar system. So it just if we could show that there's a period here, there's something actually in orbit, rules out just through process of elimination a bunch of things that sure, people have been putting their hat on to try to explain this thing because it's so bizarre. And as you say, if this is something in orbit, that has implications that really make you scratch your head more. It deepens the mystery, really. It doesn't. It may help rule out some of the explanations, but in many ways, it really does deepen the mystery in potentially some profound ways.
Now, in regards to the 1572-day periodicity, this would place that within the habitable zone of this star, right?
Yeah, we calculated about 2.9 AU, so that's about 3 times the distance of Earth is to our sun. But this is a much bigger star, a lot hotter. So being 3 Earth lengths out from the star is the Goldilocks zone. It's going to be the right temperature if we were hoping to find life.
Now the infrared mystery. So if it's that close in, it should be detectable in infrared, but that didn't happen. Do you think it's just below the threshold of what we can detect, or is that correct to try to reestablish if there's any infrared emission from the star?
Well, if there's dust and it is at that, if it's 1,574 day period and it is 3 astronomical units, then you should see infrared excess, and we don't. So, we certainly will look deeper at that. I think if we get a big dip in the very near future and we're on the ground watching and we've got some filters observing, maybe we'll actually be able to detect the infrared, in a way we haven't before. So I'm hopeful. Kind of a follow-up to your point around the period. So we know we've had 1,574 days between the dips in 2013 as part of Kepler, between that and the 2017 dips. What's so interesting about the time we're in right now is that this is when we should be expecting the first dips, if 1,574 days is correct. So September 10th is the date that I had circled on my calendar looking for the first dip to occur. And sure enough, we have had a dip recorded here for the first time in a long time. Actually, the star has been relatively quiet. So suddenly, out of the blue, we now have a dip that has occurred, and is the star maybe actually active as we speak. So that would, and when we talk in astronomy, usually periodicity is confirmed on 3 successive observations of transits. So when we're looking for planets out there in orbit around stars, for statistical significance of that, to show that we have a period, we want to see that transit occur 3 consecutive times. So the period we're in right now, these next days, weeks, and months, really will tell us if it really does have that period of 1,574 days. I think, because if we can show that the dip just occurred is one, and then we get the follow-up dips in October, on October 13th, and then so forth and so on, then I think we can be confident that sure enough we have something in orbit close to the star.
This material that is obscuring the star, there's one thing we do know, that there's a difference between red and blue light, which screams dust. Very, very, very tiny dust. Matter of fact, it's smaller than cigarette smoke, something like that. So whatever it is, it's very tiny, and it is not a solid object, because if we'd have seen that, then we'd be talking about gigantic alien megastructures. But this is something else. This is a phenomenon of some sort of very, very fine material. Now, what that creates actually an even bigger problem, maybe, than the idea of somebody building a Dyson Swarm or Dyson Sphere or something like that. That should get blown out of this system. That star should be blowing this material out very rapidly. Why isn't it?
Yeah, you'd have to understand the mechanism for which it's being replenished. There's clearly something replenishing the dust. If this is in orbit, something is replenishing it. Otherwise, you'd have to start talking about, many comets that are larger than comets that I think we've been able to see before. So the planetary size, stellar sized comets that are just absolutely massive, and many. And there's just some other data points that also would, I think, be strange. For instance, the depth of the dips that we're seeing now, if they turn out to be the same or bigger, it might be even weirder if the dips are bigger, because if the same comets are coming around, why are we seeing more now than we did before? And that says nothing about the secular dimming. Why is the star over 100 plus years fading? I mean, if this is stuff in orbit, why is stuff growing?
How pronounced is the secular dimming? Meaning, how much over the last 100 years has this dimmed as far as the percentage goes? Meaning that, nature usually likes to work on geologic timescales. Huge, millions and millions of years, and you might see some sort of dimming like this occurring. But this is happening very rapidly, is my sense. So, as a percentage,
yeah, it's extraordinarily rapid. So from 1880 to 1880 to 1989, I think it was, this Bradley Schaefer looked at Harvard plates and found that the star dimmed overall by 20%. So that's somewhere on the order of 0.2% per year.
I also have to give a quick shout out to Bradley Schaefer, because reading ancient photographic plates from 100 years ago is a dying art, and there will come a time when we can't do that.
Yeah.
And that the skills will be lost. But he is definitely the world's expert in that.
Yeah. But just to add to that, and why we should all look at his work and have some level of confidence that it's correct, is because he's since then been supported by multiple other sources. So for one, Benjamin Montet and Joshua Simon published a paper where they studied the Kepler data during those 4 years. And apparently there was some ingenious way that they were able to figure out baseline dimming. And so when they did that, they saw that the star itself was also fading during those 4 years. And so that I think during the first 1,000 years, it was dimming at something around the line of 0.2%, I think, for the first 1,000 days. And then in the next few hundred days, it dimmed more quickly than that. So you've got another source to support what Schaefer was seeing. And then, of course, the work that I've been doing with Tabby is to really confirm that secular dimming. So we've been, for 3 years now, been taking a photograph, taking an observation once a week. And for the first 2 years, we were able to compare. Of course, this year's not over yet, so we have to wait till the season's over to really know if it's dim. But from season 1 to season 2, we saw the dimming of that star. So it's faded about 0.27% on average. Well, I think it's 0.28% in I band and 0.26% in B band. So again, consistent with what Bradley Schaefer was seeing, consistent with what Benjamin Montet's been seeing in the first 1,000 days that he looked at the data in Kepler. So it just seems to be dimming at about 0.2+% per year.
So that's extraordinary. So is the current thinking that the two phenomena, the two types of dimming, the short-term and the long-term, are due to the same phenomenon, or could we be seeing two separate bizarre phenomenon happening to this star?
It would I mean, look, anything's possible, right? But to me, it would be really strange to have two bizarre, absolutely bizarre mysteries happening at the same star that are unrelated to each other. Like, that just makes no sense. And this is why this period is so important, because if we can rule out intrinsic variability, that it's not the star itself that's sick because it's something in orbit, I mean, that combined with the secular dimming is really deep into mystery. What the heck is going on there? I mean, it's hard to come up with an explanation now, right? You'd have to do something plausible, say massive comets. But even then, right? You don't, even if it's massive comets, the massive comets don't explain the secular dimming, right? I suppose you could make an argument that, you know, they've created some plane of dust and debris, and the plane is moving, right, toward the Earth's line of sight, and it's running through a thicker patch of that. That would be one way of trying to tie the giant comets. But then how do you have giant comets that without infrared access, right? So like, it's just every time you try to plug in an explanation, when you've got the secular dimming with this period, you're just left scratching your head. Like, you just can't make sense of it.
With the two types of dimming, we don't see this with any other stars. And when you look at comets, and presumably even a planet-sized comet, gigantic comet that we've never seen anything like before in nature, there was a paper that showed that exocomets in the Kepler data have quite a bit different of a light curve than what we see at Tabby stars. So they sort of have a little hook that seems to be characteristic. Do you remember that paper?
Man, which paper? Sorry.
It was a paper that they identified exocomets in the Kepler light curves.
Oh, right. Yeah.
And they don't really look like this.
Right.
Now,
exactly.
This brings us to one very strange feature in the Kepler light curve for KIC 8462852. I believe around day 800, there was a very smooth ingress and egress that can be interpreted in a number of different ways. You can model it in different ways. But one was a giant isosceles triangle. And that could be a comet, but it would have to be a comet, I believe Boyajian said, that was flipped around somehow. You know, apparently there's a mechanism for that. But there's also Luke Arnold and the idea of putting up giant mylar baffles in shapes that you shouldn't see in nature. So it kind of looked maybe like that. So we have an alien component here. But the thing is that this is not solid material. This is dust. And we can measure that. But can you think of any option as far as the potential of an alien civilization doing this? Or did this 1,500 years ago that starts 1,500 light years away?
Yeah.
Or more.
Yeah.
Can you think of anything? I mean, what about asteroid mining? Is there anything plausible without getting into aliens of the gaps?
Yeah. Well, I'm not a big fan of the alien of the gaps. I do understand it. You have to be careful, right? But, you know, and I'm also, by the way, not a fan of this idea of extraordinary claims require extraordinary evidence. You know, can we just simply stick with the scientific method, which has done a pretty nice job since the 17th century, systematically validating what we know about the world around us. So, like, you have quantitative observation, you have hypotheses based on observation results, and you do experimentation to support the hypothesis. So, predictions and experiments to actually support it. I do believe there's a place for skepticism, because bias can distort how we maybe interpret observation, but I don't think we should be eliminating ETI or extraterrestrial intelligence as part of any hypothesis, because that would be extraordinary. Because, and this is the part that frustrates me, if ETI exists in the universe, and most in the science community will tell you that it does, then ETI is not extraordinary. So it's a little bit strange. And if you do eliminate ETI, like if you do eliminate ET for all possible hypotheses, because you have this extraordinary evidence requirement in your scientific method, then you've created a loophole in the scientific method, so that if you ever had ETI actually present in any observation, whether that be UAPs here on Earth or creating dust clouds near a star system near us, the loophole will essentially be that we have to have a hypothesis other than ETI because you can't use it, which then means you always will have an incorrect hypothesis when ETI is involved. So the fact is, you never end up with a scenario where you have a hypothesis of ETI unless you have extraordinary evidence. And then you come into the quandary of what do you consider extraordinary? Well, I think many people would consider extraordinary a little green man landing on the White House lawn and doing a press interview, right? Other than that, it's not extraordinary. So it's just a difficult conversation to have. There's a lot of there's a lot of bias when it comes to this. But I think the more our technology advances, the more we're going to be having to deal with this fact. I think one thing you could look at to explain some of this, and I'm not sure we can fully explain the lack of IR yet, or infrared yet, access, is there was a paper produced about 4 years ago where they looked at that dip you talked about, day 800, and showed that this fit a star lifting model in a pretty precise way. So star lifting is this idea that, so in a very simple way of describing this is that sufficiently advanced civilization could induce solar flares or stellar emissions of some kind, and then using magnets, trap that material in a certain orbit, allow it cool, and then mine it. And then obviously there's certain elements you would be interested in theory, and the other elements would be waste material. And if you were smart, you would make sure the waste material is fine enough not to cause damage. And so you also fine enough to blow out the system, because you want your system to be clean, especially on the inner side of it, the inside of it. So wherever you're doing your mining, you do it outside where the work is being done, because there's going to be debris, and that debris is going to blow out. So, yeah, I mean, that's one hypothesis that ought to be considered here at this point.
Now, that's interesting that you make the point of extraordinary evidence. Well, the fact is, merely evidence will do. And if you start adding in the word extraordinary, then we ourselves become extraordinary. In other words, we suddenly step outside of the Copernican principle, and we're suddenly special. If we say aliens, we need extraordinary proof of them, we would also need extraordinary proof of our own origin, and that doesn't seem to make much sense. So if you see an alien civilization, then that's what it is. Now, I wanted to ask you, somewhat related but not entirely, what's your view on this UAP business? Now, I just left a symposium that Harvard is giving regarding looking into this, the Galileo project. You think that has any legs? Do you think that we might have missed the presence of an alien civilization in our own solar system?
I mean, that's what it looks like. I don't know how else to explain it. If you just look at the evidence, right? So we see something almost every day, if not every day. Our Navy pilots are running into something that is outperforming our technology. Now, you could say, well, it's U.S. technology, but there's a protocol, right, for black projects, and there's a couple basic things. One, you have the pilots interact with it, sign NDAs, not talk about it in the press like it has been. Two, you don't do it over international waters where there's surveillance going on. Plus, if you lose the equipment, you don't want to lose it in international waters, right? You do it over the inside part of your territory, like the Nevada desert. You don't do it out over international waters. So there's a lot of wrong about that. The second thing that you could throw away with it being U.S. tech is, these same things that have been reported by other pilots, documented, reported by pilots, date back to the 50s, doing the same maneuvers. So clearly we didn't have that technology in the 50s. So we've got video, we've got radar, we've got infrared imagery, we've got witness testimony, all pointing to the same exact thing. I'm sure we have other data as well. I'm sure there are much better video. I'm sure there is satellite video, etc. But just on the evidence that we've actually seen and it's been confirmed by the military, I'm not sure how else you are to interpret this. It's hard to rationalize an explanation here. Right? If it's an adversarial technology, it's hard to believe that they had it in the 50s.
Right.
It's hard to believe when the U.S. spends combined more than every country on the planet on military, that an adversary could leap us on the order of decades, right? Because think about this. This was 2004 that the first F-18 pilots captured some of these videos. So that means this technology is still outside of our grasp by 50 years or so, right? So that means in 2004, it had China or Russia had this technology, but we don't have it yet. What, 20 years later? It's just you have to. I mean, you really have to you really have to stretch your window here for what's believable or not, to actually buy in that this is some sort of adversarial technology or even U.S. technology. It just doesn't make any sense.
And especially considering, the adversaries have basically changed since people started seeing these things, which, I mean, they've probably seen them throughout history, but when we really started paying attention in the 1950s, China in the 1950s was not the China of today. And they, it's very hard to believe that they would have been pursuing any kind of technology like that, in the age of Chairman Mao. Then the same with Russia. This is Stalinist Russia, where everything was suppressed. So it's interesting that these phenomena that they're seeing seem to go back that far, because you're right, it eliminates human technology. And even now, we don't have anything that can go that fast the way that they're being reported. The G-forces and everything else that are involved. But there's a plausible way for an alien to work. The argument has always been that, everything's too distant for somebody to be here. But that's not really true, because distance is really only a matter of time, and if you're a machine, you may not care. Which is what led Enrico Fermi to postulate the Fermi paradox, is that why don't we see them? They should be everywhere, because the galaxy is well old enough for a civilization to have sent out von Neumann probes and colonized the whole thing. So it isn't really that much of a stretch to say that there's a von Neumann 3D printer sitting out there printing out probes, and they're dipping in the atmosphere, and we'll see them. And they're studying us. Maybe they're here for science, like we would. We would love to go to an exoplanet and study a biosphere. We would actually cross space-time to do that, so why wouldn't they? So it's interesting in that we may have talked ourselves out of the idea of an alien civilization being here, and we may have talked ourselves out of it at KS 8462852 and just missed it.
Yeah.
We missed it.
Yeah, and I to your point around too far away, that presumes we know enough about physics to believe that. I struggle really having much faith in our scientific maturity as a civilization to know that, or even rely on that in any way, shape, or form. If you go back 500 years ago, you had Columbus coming across the ocean in a wooden ship by power of wind. That was 500 years ago. Now imagine if, I'm gonna steal a analogy from an author where he describes this scenario where Columbus is sailing across the ocean, and pops up next to him is a nuclear submarine. And it just looks weird, right? I mean, it's just an odd looking thing, first of all, but then secondly, it's under the ocean. Why travel under the ocean, first of all? But second of all, think about its propulsion and how many generations and step changes that propulsion is beyond what Columbus, the scientists of his day, would have even been able to comprehend. So, for example, splitting of the atom. Like, first of all, what's an atom, right? So their maturity, their scientific maturity was such that for sure they would have said it's impossible to travel from Europe or travel under the ocean at all, right? In a nuclear powered submarine, because they couldn't even comprehend fission, let alone, right, what they were looking at. So this idea that we're sitting here saying that they're just too far away, when you could have civilizations literally, not just millions, in theory, billions of years more advanced than us, it's just silly, right? Because 500 years ago, we didn't have machines. Just 500 years. We're talking in orders of millions, if not billions of years of advancement. So I just struggle with anyone who comes out saying just too far away. I just don't get that. I don't get that. It doesn't make any sense. That's assuming it's almost assuming we've pretty much figured it out. We pretty much understand physics, and we know that Einstein's theory prevents us from ever going faster than the speed of light. Well, maybe it does. Maybe it does in some ways. I'm not so sure. You can't get around it. But I don't know, right? I don't know the answer to that, of course. But I just know that we're very immature as a civilization. And just to make statements that they're just too far away, I just struggle with really feeling comfortable with that. I don't know. They are.
It's worth noting that in Christopher Columbus's logs, we have excerpts of them. We don't actually have the logs themselves, but we have excerpts. He saw a UFO. He saw a light in the sky that he couldn't identify, and this was a master navigator, which would have, in his day, would have been intimately familiar with the stars. So I just had to note that. Now, in regards to Tabby Star, getting back to that. Now, what with this current dip that seems to be happening, that's reported by one observer, and I guess maybe other observers. I mean, do you use the AVSO data and look at what, photometry, other people that look at variable stars are doing?
Yeah, absolutely. So we did pick up a dip a few days ago that reached as low as 4% in I band. I think the lowest we saw in B band was 2%. However, an asterisk on that, the night we saw the 4% dip in I band at LCO, we couldn't get a B band reading at all because it looked like, if you look at the frames, and this is part of the frustration of astronomy, but if you look at the frames, there appears to be a passing cloud. So the sky lit up, it got bright. I basically had to throw away the data for that night for the B band. I band, it was clear. It showed about 4% down. And then it recovered. So around September 9th, our prediction was on September 10th we'd see the dip. So it's this dip started, as typical with these Tabby Star dips, they last for days. I think it started around the 6th or so, peaked on the 8th, and then recovered by the 10th. And now appears to be, based on one observer as of last night, to be falling pretty rapidly. So we've scheduled an LCO observation for this evening to see if we can confirm that. What's interesting is, if you look at the Kepler data and the light curves there, and also the light curves of the observations made in 2017, this star has an unusual series of these dips. You see often you'll see a shallower dip followed by a really, really, really deep dip. And that may be what we're about to see here. What would be really interesting, though, is if, when this all shakes out, if it turns out that September 10th is right in the middle, right? This is all one dip. And what does that mean? Does it mean we've got two pieces of it now? It's hard to explain, why you would see a dip occur on 1,574 days ago before September 10th, having one dip, and then when it comes back, it now has two dips. I guess it could have been torn apart, but that's just typical of what you see at the star. You see these kind of double dips, or even in some cases a triple dip. So just, we don't know. That's the exciting part about this. It's happening in real time. We're going to know in a day or two actually what's going on, and it may help either create more intrigue, which I suspect it will, or maybe it'll help lend some insights to what's going on. I'm betting on more intrigue. I don't think we're going to solve this mystery anytime soon.
Oh, I having been following this since 2015, I can tell you the solid bet is more intrigue because the star just keeps confounding everything that's thrown at it.
Well, the one thing too, John, what's fascinating to me was when Tabby published her paper on this, the WTF paper. She found that, that one dip you talked about, the day 800 dip, actually I think peaked on 792 or something like that, and then there was another dip at like 1519, and it just turns out that that's exactly 2 Earth years, 2.000 Earth years apart, which is just so weird, right? What does Earth time have to do with it? But another weird, interesting interval piece of that whole thing was that if it just so happens that all of these dips that occur around the star, there are multiple of them, right? There was one at like Kepler day 260, one at day 140, one at day 793, one at 1200, one at 1519, and so forth and so on. But these all are on the same period. That means they're all in the same orbit around the star, as if something's broken apart and it's just in orbit, and they're all beads all on the same orbit. Well, but what's mathematically strange about it is that she noted that the time, the number of days, Earth days, between each of these dips tended to be some multiplier of this 24.2 days. So it's just bizarre. It was, first of all, in her first paper, this is before the 2017 observations, just based on the Kepler data only at that point, she noted this 24.2 day period or multiplier between these dips. So it's just kind of a quirky thing. She pointed out it's kind of a strange thing. Like, why is that? Why are they all multipliers 24.2? So then fast forward, 2017 happened, we have more dips, and I'm able to come up with a paper that shows potentially a 1,574 overall orbit period. So all these objects on the same orbit, all traveling, taking 1,504 days to go around the star. So what's even more strange is that if you take 1,574 and you divide it by 24.2, you end up with 65.0 periods. So it's a round number again, right? So 65 even periods of 24.2 days equals 1,574 days. So it's just again, very, very strange. Hard to explain.
Nature does periodicity, but that's weird, and especially correlating to 2.0 Earth years, and it doesn't make any sense. So let me ask you this: could this be a possibility to go back to Luke Arnold's work? Could this be a signpost, something saying hello, and that just aliens think so differently from us that it is not immediate evident that this is a contact signal?
It could be. I doubt it. To me, that just, it's a little contrived in a way that, we're trying to make sense of something, right? Naturally we want to look for patterns, or I just think though, if this is ET, they're just doing their thing, right? We're just seeing the outcome of whatever their thing is, and they're going to do things on cellular scales, right? So if they need materials in a grand way. Where do you get materials? Stars. So if this is ET, I just think they're doing their thing, and we're just seeing sort of the outflow of it. We're just seeing the dust from it, the debris. And given that oftentimes our technology and our own work can be periodic, it might produce patterns like that, right? Yeah, well, that's exactly right. So I would suspect that there's some order in which things are being done, right? So if you look at an assembly line, right, you could for sure see periods in the product coming down the assembly line, one product to the next, to the next, to the next. There's going to be some order to that, timing and pace. So yeah, if there's intelligence involved here, you should expect to see some orderness to whatever's happening.
Now, in regards to the future, what is the future of observations of the star? What can you look at I mean, let me ask you this. Let me change gears here. Has anyone ever looked at the star itself and looked for peculiarities in its chemical makeup?
Yes. Yeah, nothing unusual was found. But yeah, I mean, the idea to try to rule out, something wrong with the star, it's been looked at, and nothing really has, there's nothing unusual about the star at all from that perspective.
Now, what's the future? So what observations can we use to further constrain what's going on with the star, what the possibilities are? What else can we do?
Well, the James Webb telescope has been launched. That's a game changer, for sure. And I have no doubt it's going to be, one of its objects is going to be, well, at least this patch of sky. We're going to be able to get data about the star from that telescope. There's no doubt about it. And that is a game changer. We will be able to see the dust in a way we can't see it today. I think we'll know if there's infrared excess there. I just think the data will be so rich that we'll at least be able to, in my mind, be more conclusive about plausible explanations. Although, again, getting back to our earlier point, if this is truly ET generating dust, I'm not sure, given today's culture, I'm not sure that we'll come to that conclusion. Right? I'm not sure what conclusion. It may just stay a mystery for a while. Right? We may just be able to, at some point, I don't think James Webb is going to be able to zoom in and see, for example, a machine, right? So that's not going to happen. We'll see dust. We won't be able to explain why it's being replenished. So John, to be fair, hopefully, or to be optimistic about this, maybe at that point we will get some hypothesis around ET. And maybe those things will get published, right? They'll get put in papers and they'll get published. We'll just have to wait and see. But I'm looking forward to James Webb. Good question. That telescope is going to shed a lot more data in a very rich way, which we haven't had today.
I think the favorite scenario that I've thought of is that one day we get a radio signal from an alien civilization, and by some miracle we're able to decipher it, and the aliens are asking us what we think is going on with KSE 8462852. No one in the galaxy actually knows. It's even weirder than aliens.
Yeah.
All right, Gary.
Right. It's like some kind of test.
Yeah, exactly. It's just an alien civilization messing with everyone, just trolling. All right, Gary. Before we release this, we're going to check back in with you in 2 days and see where this dip is. So I will talk to you then.
Sounds good.
Anna, why is the studio full of swamp gas?
It's an alien, John. And that's its atmosphere.
Yeah, alien in my studio. I should be absolutely astonished, but somehow I'm not. So, Anna, why is the possum talking to the alien?
He's gone directly to the source, John. Why do humans assume that they're the smartest mammals on the planet? Instead of wondering about the UAP, he simply asked the alien directly.
What? It's not a baby. It's not a cat either.
Shield activated.
This is Ed Sheeran with his brand new single, Shivers. Out now.
Cargo scoop retracted. deployed. Cargo scoop retracted. Cargo scoop deployed. Cargo scoop retracted. Handbrake is on. Drive assist on. Drive assist off. Fuel replenished. Cargo scoop deployed. Cargo scoop retracted. Ship recalled. Landing gear retracted. Charging. 4, 3, 2, 1. Engage. Landing gear deployed.